Hey guys, so today's lesson is the last lesson of chapter 1, and it actually encompasses a bunch of different things. So we're going to be reviewing BEDMAS, we're going to be reviewing how to isolate a variable, and then we're also going to look at writing equivalent expressions and solving word problems and stuff like that. So this is a bit of a longer lesson, also has word problems in it, which I know are not a lot of people's favorites. But then we're going to be done chapter 1. Okay, so this is lesson 1.5, which is all about the order of operations. So the first thing I want to go over is just a reminder of what the order of operations is. Essentially, it's BEDMAS, which is how you probably have heard it referred to before. So that stands for brackets, exponents, division, multiplication, addition, and subtraction. And when it comes to division and multiplication, as well as addition and subtraction, it's actually whichever in that pair comes first. What that means is if you actually have multiplication showing up before division, then you would do the multiplication first. So it's brackets, exponents, then whichever either multiplication or division comes next, and then either addition or subtraction, whichever comes first. So let's look at an example of what I'm talking about. So I have 8 times 3 minus 4 divided by 2 plus 3. So step 1 is to do our brackets. So that is solve anything that is inside of brackets. So 3 minus 4, which is -1. And then there's no exponents, so we don't have to worry about that. And then we're on to division / multiplication. Now, even though the D comes first in BEDMAS, we're going to do multiplication first because it comes first in the equation. And when it comes to division or multiplication, we do whichever comes first. So I'm going to do the 8 times -1, which is -8. And then now I can do my division. And then the subtraction comes last. So my answer would be -1. Okay, the next thing I want to review is how to isolate a variable. So when you're isolating a variable, that means you're getting the letter, which is the variable, by itself. In order to do this, we use opposite operations to move terms to the other side of the equal sign, so away from the variable. Whatever you do to one side, you must also do to the other side. We're going to start by moving whatever is furthest from the variable and then get closer to the variable. And if the variable is part of a fraction or part of division, then the bottom of the fraction or the second term in the division must be the one to move. And we'll go through 2 examples to kind of show you what I'm talking about here. Okay, so we'll start with this example here, 3x divided by 1/2 minus 4 equals 20. So we want to get the x by itself, which means that everything else on this side of the equal sign needs to get moved to the other side. And again, we're going to start with the thing that's furthest away from our variable. So we'll start by moving this -4 to the other side. And we use our opposite operations to do that. So because this is -4, I will add 4 to move it to the other side. -4 plus 4 cancels out. And then what I do to one side, I must also do to the other side. That will leave me with 3x divided by 1/2 equals 20 plus 4, which is 24. The next thing that needs to move is this 1/2 because it is further away from the x than the 3 is. So this right now is dividing by 1/2. I will multiply by 1/2 to move it to the other side, since division and multiplication are opposite operations. So that will cancel out there, and then I have to do the same on the other side. That leaves me with 3x, and then 24 times 1/2 is 12. And then my last step is to get this 3 away from the x. Right now it is 3 times x, so the opposite of that will be to divide. That cancels out. What we do to one side, we must also do to the other. So our final answer will be x equals 4. Okay, this second example here is a little bit more complicated just because of where the x is, but I'll show you how to go through this one. So again, we're going to start by moving the thing that's furthest from the x, which is the 4. Now, even though there is a minus sign behind the 4, this is a positive 4. So when we're looking to see what kind of operations are involved, whether it's like adding or subtracting, we always look in front of the number. And so if there's not a minus sign there, then this obviously isn't a negative 4, it is a positive 4. So the opposite of a positive 4 is subtracting 4. That's how we get those to cancel out to equal 0. 4 minus 4 is 0, it cancels out. And then of course, what I do to one side, I must also do to the other. 10 minus 4 is 6, and on this side, the important thing to notice is that this minus sign hasn't gone anywhere. It didn't get canceled out. Signs always go with whatever is behind them. So in this case, the 2 over the x. They don't go with whatever's in front of them. So this minus sign did not go with the 4, it stayed with the 2x. So I have negative 2 over x. This went from being a minus sign to a negative sign. The next tricky part here is the fact that, like I said, if you have division, the thing on the bottom, or the thing on the bottom of the fraction, needs to be the thing to move. So even though this is my variable, because it's on the bottom of this fraction, it has to be the one to go. So I'm actually going to be moving the x to the other side right now. So right now we have 2 divided by x. The opposite of that is, of course, to multiply by x. That'll cancel out, which means I also multiply the other side by x. That leaves me with negative 2 equals 6x. Now I can get the x by itself by moving the 6 away from it. Since this is 6 times x, I will divide by 6 to cancel it out, which means I also divide the other side by 6. So my final answer here, negative 2 divided by 6 is a fraction. We can leave it as a fraction and just put it in lowest terms. So it would be negative 1/3 is my x value. Okay, the next thing I want to talk about is something called equivalent expressions. These are expressions that mean the same thing, and usually the only difference between them is how we represent division. So for example, if you have 3x plus 4 all divided by 2, that is equivalent or equal to 3x plus 4 divided by 2, written like that. It is not equal to 3x plus 4 divided by 2 if we don't put any brackets in. And the reason for that is that if we were to solve this first expression, we would solve the top first, the 3x plus 4, and then we would divide by 2. Same with this expression. We would do the 3x plus 4 first, since it's in brackets, and then divide by 2. But if we were to look at this last expression over here, well, division comes before addition. So we would actually do the 4 divided by 2 and then add the 3x. We would be doing it in the wrong order compared to the original expression. So you have to put these brackets here around whatever is on the top of the fraction in order to show that we would do that first before we divide. So that's kind of like a common rule, is that whatever is on the top of an expression, if it's a fraction like this, needs to be in bracket. Same with if there was multiple things on the bottom, you'd want to put that in brackets as well. And then you can get rid of any brackets that aren't needed to show that something goes first. Okay, the next thing I want to go over is how to write expressions. Okay, for this next example here, this is, you can think of it as like a window or a bookcase, doesn't really matter. The height of the entire thing is 200 centimeters. Each one of these little spaces in here is 2 centimeters. And then this in here, we don't know the distance of, and all three of these would be the same. It wants you to write an expression to represent this distance, the distance of x in here. So the way that we would do this, if I asked you to just solve this, most of you would probably do it in a bunch of steps. However, if you need to write the expression for it, you need to show how it could be done all in one step. So we're going to say that x is going to be equal to, and then we have to say all the things we need to do to these numbers in order to find our value of x. So I'm going to start with the entire distance here, this entire 200 centimeters. And what I'm going to do is subtract the part of this 200 centimeters that is not these x values. So this part is an x. This would also be an x. That would also be an x. These parts, this 2 centimeters here, this 2 centimeters here, this 2 centimeters here, and this 2 centimeters at the bottom are not part of those x's. So I'm going to subtract the 4 2 centimeters sections, 1, 2, 3, 4. So subtract the 4 times the 2. That leaves me with only these x values. But there are 3 of them here, and I just want 1. So all I'm going to do is divide all of that by 3 to get just 1 of those x values. Okay, that's it. That is how you would write the expression for that. Okay, so this is the word problem that we're going to work through. James took 60% of his $345 to the mall. He spent 2/3 of it on clothes. He spent 1/5 of the remainder on food. How much money did he have left over? So the first thing we're going to do, our very first step, is going to be converting any percentages that we see into decimals. So 60%, in order to figure out what that would be as a decimal, all you do is divide by 100. So that is actually 0.6. And we do that because when we're doing calculations, you actually cannot use percentages. You have to convert them into decimals first. Our second step is going to be to figure out what is 0.6 or 60% of $345, since that's how much he took to the mall. Anytime you see this word of, it means multiply. So what we're actually going to do is 0.6 times 345, which is 207. So he brought $207 with him to the mall. Brought to mall. The next thing it says is that he spent 2/3 of that. So we had to figure out what is 2/3 of 207. So I'm going to do 2/3 of 207. Remember, anytime we see this word of, it means multiply. So 2/3 times 207, and that is $138. So that's how much he spent on clothes. Then it says that he spent 1/5 of the remainder on food. Well, before we can figure out what 1/5 of the remainder is, we have to figure out how much money remains. So he took $207 with him to the mall. He just spent $138. So that was step 3. Step 4 is to do the 207 that he brought minus the 138 that he spent. That tells us that he has $69 remaining. Now we can figure out what 1/5 of the remainder is. So that will be step 5, 1/5 of the remainder. And remember, of means multiply. So 1/5 of the $69 is going to give us $13.80 spent on food. Then it wants to know how much money did he have left over after that. Well, if he had $69 before he bought food and then he spent $13.80, we can just subtract those to figure out how much money he had left. So $55.20 is how much he would have had left over. Okay, so when you have a word problem like that and it's actually asking you to solve, that is when you are allowed to break it down into as many different steps as you would like. Okay, it's not like when you're writing an expression and you have to do it all in one step. This can be done in multiple steps. Okay, that's it for today. Let me know if you have any questions.